Okay, so objective 3. So now we're going to use a normal approximation to calculate probabilities involving p hat. So our example here says, how far from home do you attend college? A polling organization asked an SRS of 1,500 first-year college students how far away their home is. Suppose that 35% of all first-year students attend college within 50 miles of home. Find the probability that a random sample of 1,500 students will give a result within 2 percentage points of this value. Okay, so a couple things. Let's start with building the model. So the first thing I have to do is I have to find the mean and the standard deviation. So again, we look for our p-value. Our p-value is right here. That is our population proportion, 0.35, and our n value. And our n value is 1,500, SRS, right? SRS of 1,500. So to find the mean of our sampling distribution p hat, we're going to take n. I'm sorry. It is going to be equal to the population proportion, 0.35. Okay? 0.35 if you want to be fancy. All right. And now to find the standard deviation of our sampling distribution for p hat, we have to use this formula. So it's p times 1 minus p divided by n, all inside of a square root. Okay, let me go to the graphing calculator and show us. We're going to lose this information, but I'll bring it back up in a second. Okay, just because I think it's important to show you how to do this. Okay, so again, the first thing I would do is I would get my square root. So it's down here in the keyboard, square root, and I would immediately press a fraction key. So that means that the entire fraction is inside the square root. And it was 0.35 times 1 minus 0.35, and then arrow down to the bottom, and that's 1,500. And again, be smart when you do your rounding. So it looks like what would be best to do is do 0.0123. This 1 does not round the 3 up. So let's go 4 decimals, 0.0123. That's going to be our standard deviation for our sampling distribution. So if I come back here, so my mean is still 0.35, and we just calculated our standard deviation to be 0.0123. Now, these two things will help us build our normal distribution. So let's double check to make sure we even have an approximately normal distribution situation by doing the large counts condition. So now we're going to do the large counts condition. So the large counts condition says take n, multiply it by p, and see if that's at least 10. Well, I'm going to do it in a dinky calculator off to the side. So 1,500 times 0.35. That's 525. Yes, that is at least 10. And now do n times 1 minus p. And that's 975. And yes, both of these are at least 10. So this distribution can be approximately normal. And we can do the problem using our normal distribution. Okay, so that's like the backup work, not the front end work, right? So now we need to come up with a probability statement. All right. Well, it involves this phrase right here, within 2 percentage points of this true value. When you see this within 2 percentage points, you should be thinking, and I'm going to do it up here, plus or minus 2%, which is plus or minus 0.02 in proportion talk. So if you look at this p-value, this true value, okay, we're looking at 0.35. I'm going to come down here now, plus or minus 0.02, which results in 0.35 minus 0.02, which is 0.33, and 0.35 plus 0.02, which is 0.37. We have two values in this problem. So we're trying to calculate the probability that our sample proportion p hat is in between 0.33 and 0.37. That's our problem, right? What is this probability? Now, you know on your stats applet, we do have the ability to find probabilities in between two values. So that's what we're going to do. But now it's time to standardize this, right? So this is my probability statement from the context. Now I want to standardize this so I can use the standard normal distribution. So now comes our z-scores. We got to find two. One for 0.33. So we take the value minus our mean divided by our standard deviation. That's going to be, the top becomes negative 0.02 divided by 0.0123. And I got a z value of negative 1.626. Okay, now what's the other z value? Well, z equals, now you're going to do the upper p hat value, 0.37. And again, I think I've emphasized this enough about this idea of symmetry, right? Think about this. If I'm going 0.02 to the left of my mean and to the right of my mean, then the z value to the left is going to be negative, but the z value to the right should be the same exact number, just positive. So I did that without even calculating, but I will do it. Again, the top is now just positive 0.02, and when you divide that, you get 1.626. So these are my z values. So now my problem boils down to this, and I'll do it in red. Find the probability that my z value is in between negative 1.626 and positive 1.626. Right? This is the problem I have to solve in my stats applet. So I'm going to take a picture of those two values. Again, I try to have a good memory, but not always. And I'm going to go do it on the stats applet, and we'll just do everything else from there, okay? So when you do these big, long problems, I'm sorry, there's a lot to write down in that box on Edulastic. And again, I don't care about notation. I don't even care about the work you show. I just need to see some specific numbers, right? I need to see this. I need to see this, right, with approximately normal. It'd be nice to see this, but not necessarily. I need to see these z values. And now when I go to the next screen, I need to see your probability value, and I need to see your standard normal distribution. Okay, so when we go to the stats applet, probability, normal distribution, calculate an area because we're calculating a probability. Mean is 0, standard deviation is 1 between two values. See, that's the default. And our two values are negative 1.626 and positive 1.626. Let me double check that. And when I click calculate, there you go, 0.8961. So the probability that our z is in between negative 6.626 and positive 1.626 is 0.8961. So again, I need to see that number, this number on your screen, and then you just cut and paste this graph. Okay? So typically I make them worth 2 points in Edulastic because I know the amount of work. All right, so just make sure you go through the work. And if you have any questions at all, just stop and ask. Just stop and ask. Okay? All right. Okay. Good luck on the homework.